Alright guys, in this video we're talking about the Poisson probability distribution. This is not the very important thing in this class, but the reason we still want talking about a little bit over here is because I want you know how to identify a Poisson distribution, and once the problems give you a Poisson distribution, you should know how to find the probability of a single point or the probability of an interval or the expected value and the variance, that kind of thing. Okay. So actually, it's different from the binomial hypergeometric or non-negative binomial distributions. There is no sample experiment on which the Poisson distribution is based. Okay. Now, once we know this, let's just take a look at the definition down here. A discrete. So first of all, the Poisson distribution is a discrete random variable. Is a distribution of discrete random variable. A discrete random variable x is said to have a Poisson distribution with parameter mu. Mu is always greater than 0 if the PMF of x is P of x is the random variable, mu is the parameter. So we're going to have e to the power of negative mu times mu to the power of x, and then divided by x factorial. So x could be any number, any integers greater than or equal to 0. So you don't have to remember the exact form of the parameter, okay? Because the problem always given, and I'm not gonna test you how the PMF of Poisson distribution looks like, okay? And based on the property of a PMF, we know that the sum of x is equal to 0 to infinity, and then e to the negative mu times mu to the power of x, and the x factorial is equal to 1. So this is the sum of all probabilities is always equal to 1. That's the one of the most important properties of the probability distribution. Okay. So basically, once we know this, let's take a look at how to find a probability of interval and a probability of single points of a Poisson distribution. Actually, this I put the wrong example over here, so don't worry about this over here. I will give you another one. Okay, example. So I wouldn't write down the whole background information here. I just gave you x follows a Poisson distribution with the parameter value 2. So if we have a 2 here, which means the value of mu is equal to 2. Okay? Now I want you to find the probability that x is equal to 3. Okay? Now we know, based on what we have over here, p of x is going to be equal to e to the negative, since the value of mu is 2, e to the negative 2 times 2 to the power of x divided by x factorial, right? That's the exact form of the PMF in this case. Once again, you don't have to memorize this thing here. Once this appears on the test, it will be given, okay? So what we need to know is how to find the probability of single points. So if we want to find the probability of x is equal to 3, we just need to plug the 3 back into this formula over here. So it's going to be equal to e to the negative 2 times 2 to the power of 3 divided by 3 factorial. If you type this whole thing in your calculator, that is approximately equal to 0.18. And then that's how to find the probability of interval, the probability of a single point, I'm sorry. And then let's take a look at the probability of interval. Let's see how to find the probability x is less than or equal to 3. Of course, if we want to find the probability x is equal to 3, x could be 0, 1, 2, and 3, because x could be any integer greater than or equal to 0 from the definition here. So that would be equal to the sum of x is equal to 0 to 3, e to the negative 2, and then times 2 to the power of x factorial. So of course, that's equal to the probability that x is equal to 0, e to the negative 2 times 2 to the power of 0, 0 factorial, plus the probability x is equal to 1, e to the negative 2 times 2 to the power of 1, and then 1 factorial, and then plus e to the negative 2 times 2 squared, and then 2 factorial. And then plus the probability x is equal to 3, e to the negative 2 times 3 squared divided by 3 factorial. And then if you type the whole thing in your calculator, you will have this is approximately equal to 0.857. Okay, so and we can find the probability of this interval x is less than or equal to 3 from the calculator directly, and I'm going to show you that in another video. Alright, basically in this video, I just show you how to find the probability of a single point and the probability of an interval, and based on the Poisson distribution here. Alright, once we know that, there's another important proposition. If x has a Poisson distribution with a parameter mu, then the expected value and the variance, both of them are equal to the value of the parameter. So in this case, what is if I gave you the x follows Poisson distribution with the value of the parameter mu is equal to 2, then we're going to have the e of x is equal to the variance of x is equal to 2. Okay, so that's pretty much what we can get from the problem given here. So once we know the value of the parameter, we will have the value of the expected value and the variance directly. All right, that's pretty much all I want to talk about. This is pretty much all I want to talk about the Poisson distribution.